In finance, beta is a measure of the volatility or systematic risk of a security or portfolio compared to the market as a whole market. For example, we can ask what is the beta of a DBS stock compared to the STI index. A security beta is calculated by dividing the product of the covariance of the security returns and the market returns over the variance of the market returns over a specified period of time, as given here. So if the beta is 1, it indicates that the price activity is strongly correlated to the market. If the beta is less than 1.0, it means that the security is theoretically less volatile than the market. A beta greater than 1.0 indicates the security price is theoretically more volatile than the market. However, it is also possible to compute beta using the regression method. In this method, we regress the company stock returns against the market returns, and the beta is represented by the slope of the regression line. So in this bite-sized tutorial, I would like to show that these two methods are equivalent, and I will also verify it using Python. So we want to prove that given any regression model, the beta is given by this formula. We can use the definition of covariance and substitute the value of y and y bar, and then we do straightforward algebra. You can show that indeed beta is given by the ratio of covariance over the variance. And if you plot the return of the stock price versus the index returns, the slope will give you the beta. Let's verify this using Python code. First, we will download the DBS and the STI index from using the Yahoo Finance API, and we will plot the DBS stock versus the STI returns, and you can see that DBS stock return is highly correlated to the STI returns. We will first compute the beta using the covariance method, and this yields a beta of 1.19. Next, we will use the regression method. We perform a regression on the STI and the DBS stock using the Stacks model regression library, and we also get a beta of 1.19, which is consistent with the covariance method. If we plot the regression line over the scatter plot, we do see that it is a very good fit. This concludes the bite-sized tutorial on how to calculate beta. If you like this video, please comment, share, and subscribe to our channel. Thank you.